Alright, and I do have all the fans on as far as I can because it's hot. So toasty. Got it. Ew, okay, so today we're going to be kind of taking what we were doing with graphing lines and kicking it up a notch. We are going to be graphing inequalities. So if we don't remember, inequalities are when we have the less than or the greater than, less than or equal to, greater than or equal to. Those guys are going to be in our lines now, and we're still going to graph them. And what we're going to do in order to show the inequality part is we're going to use dashed or dotted lines, and we're going to do some coloring. We love coloring. So the dashed or dotted line will be when we have our less than or greater than. Anything with a not equals to. And when I say dash or dotted, I mean seriously, you're just going to like do. Something like that. Or you can do dot, 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 dot. I don't care how you do it, how you think about it. I feel like dots are harder to get into a straight line, but with rulers, we can do whatever tool we need to there. We use a solid line, a like regular, normal, what we've done forever for lines, these kind of guys. Anytime we have equals to. So just like we do when we have a normal equals to line, we use a regular line. We're going to use that same kind of line when we have the less than or equal to or the greater than or equal to. And to figure out how we mark the rest of the inequality stuff, we're going to use something called a test point. And a test point is going to be any point, and we're going to use an X, Y pair, not on the line. I do not care what point you pick, as long as it's not on the line. You can use, most of the time, you can use 0, 0, or 1, 1, or -2, -2, 703. I don't care. As long as it's not on the line and you can visually see where not on the line it is. Other than that, we treat it almost exactly the same. We at least start out the same way. We are going to figure out what kind of line we're drawing, and then we graph the line just like normal. Since we are graphing lines, shock of all shocks, I'm going to give you graphs. I'm getting the formatting kind of figured out, so you might not have to cut the graphs apart because I cut them in to get them to print vertically. Alright. So as always, you can cut them apart if you want to, but I do have them set up now so you can just glue the whole strip in and it won't overlap because they got this fan. Yeah, I got fans. Trying to make it easy for y'all. Trying to make it easy. All right, so we've got what is essentially an equation in standard form, except it's an inequality. What that means is when we are graphing, first thing I'm going to do is figure out if we're doing a solid line or if we're going to do a dotted line. To figure out if we do a solid line or a dotted line, we are going to look at our inequality sign. We have a less than. That is terrible. There we go. We have a less than. Is that an equals to? No. Since it is less than, but not equal to, we're going to use a dotted or a dashed line.
Does it matter which one you use?
No, genuinely does not. I tend to say dotted and do dashed. So that's why I'm giving you both words, just so that we don't get confused. Because in my head, I'm doing a dotted line, but I don't go da-da-da-da-da-da-da-da. From there, so once I know what kind of line it is, we're going to go ahead and just like plot it like a normal line. We're in standard form. This is when it's really easy to do our x, y intercepts. So to find my x-intercept, I know that y is 0, so I put my hand here. X equals 2. Be where my intercept is. See how that works? Okay, because I know it's not an actual equal sign, but it is same general vibe. We plot it just like it was the line x plus 4y equals 2. Then we get x equals 2 for our x-intercept. And to get our y-intercept, we do the same thing. Cover up the x, because my x is going to be 0. 4y equals 2. What's my y-intercept? That's the x-intercept. Get y by itself. What do I do to get y by itself here? Divide by 4. 2 over 4, also known as, 1/2. And that's okay. We can do that. My y-intercept is at 1/2, so it's right there. Those are my x and y intercepts. To make a dotted line, we make our iPad not be a jerk. We connect them up. You will use a ruler. My iPad's a grumpy Gus and won't let me, so I have to kind of eyeball a dotted line. Something kind of like that. Not the worst dotted line I've ever done. Not the worst. Yours will be better because you're going to use a ruler. If there's not one on your table, I think there's one in the box on the table. I have some tiny rulers that fit in the boxes. But my screen won't let me use them because my screen's a jerk. Okay, so there's the line part. We use a dotted line when we have a less than. Our last piece on this is we are going to have more options that are true than are just on the line. So this is where our test point comes in. Because what we're going to do is we are going to color the truth to make it bright and bold and beautiful. And in order to figure out where our true region is, we are going to take any point that is not on our line. I recommend that we pick either something easy to work with or something very, very clearly visible, not on the line.
1, 2.
We could absolutely do 1, 2, very clear. You can do 0, 0. We could do 1, -5, very clearly not on the line. I would not recommend playing around with like the -2, 1 kind of area. That one's a little close and hard to tell. I would not recommend doing like the 5, -1 kind of area. It's too close. It's really hard to tell where it is. So things that are really, stop it. Really clearly not on the line. I heard the 1, 2 first. Let's go with the 1, 2. So I'm going to pick this guy as my test point, and I draw it on there. We are going to test the point 1, 2. Remember, that's my x, y. We are going to take our whole inequality, the x plus 4y less than 2. And we're going to see if it works at 1, 2. Is that true? So we're going to substitute that in. My x of 1 plus 4 times my y of 2, is that less than 2? So let's simplify this. 1 plus 4 times 2 gives me 8, is less than 2. Is 9 less than 2? No. This is false, which means this is not where my solutions are. To color in where my solutions are, I'm going to need to go on the other side of my line. So this is not where my solutions are. If this one doesn't work, then this one doesn't work, then this one doesn't work, then this one doesn't work. So this side of my line has all of my solutions. So what we're going to do is we are going to get a chunkier pen than that. Color in everything on this side of the line. We pick any point not on the line, and that tests that side. Because anything down in this colorful area, in this pink area, anything down here would give us something true. And you can test that. You could do another test point. If I put 0, 0 in, 0 plus 4 times 0, is that less than 2? 4 times 0 is 0. 0 plus 0 is 0. 0 is less than 2, so this one's true. So the test point, it doesn't matter what side we pick on, just that we pick on a side. So these are weird and a little tricky to get used to. Questions on this first one. We're going to do 3 more like this, or 2 more like this. Okay. Our next one is y is greater than or equal to 2x minus 3. And again, before I start graphing, I want to figure out if this is going to be a solid line or a dotted line. So we look at our sign here. Is this going to be a solid line or a dotted line? Solid line, because it has that equals to. What we're doing is we're kind of doing closed circle, open circle, if you remember that from when we did like number line inequalities back in Algebra 1. Just making them as lines. It's the same kind of dealio. And then we graph this line like normal. This is in slope-intercept form, y equals mx plus b. And that's exactly what we're going to graph. A related function of y equals 2x minus 3. That's the line we graph. Where am I going to start when we're graphing this line? You gotta say it louder, all the fans are on. We're going to start at -3 at our y-intercept. You're absolutely right. So we start at -3, that b value, y equals mx plus b. And how do I move? Get my next point? Over. How many? Over 1. Up to over 1. You're exactly right. Have confidence in yourself. Up to over 1. Up to over 1. Up to over 1. And then we're going to do a solid line, which I love those. I can use my tools. Yay. Solid line. Should look like that. But since it's an inequality, we're still going to need to test a point. And we can pick any point that is not on the line. I genuinely do not care what point you pick. There is one point that if it's available, meaning if it's not on our line, it does make our lives easier. If 0, 0 is not on your line, I highly recommend it. We have to think less because 0 times anything is 0. Absolutely fine to use any point you want, but 0, 0 is the easiest one to work with if it meets that not on the line condition. Okay? And that's what we're going to do. We're going to take our inequality and we're going to test the point 0, 0. That's a comma. So we're going to substitute into our inequality. 0 is greater than or equal to 2 times 0 minus 3. And we want to know if that's true. So we have to simplify it. 0 greater than or equal to 2 times 0 is 0 minus 3. What is 0 minus 3? Negative 3. All right. Is this true? Is 0 bigger than or equal to negative 3? Yes. Which means that our test point is true. This is a solution, which means anything next to it. Sorry, my screen's a jerk. So if this is true, then this would be 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 true. Like, I can work my way out. Anything on this side of my line is going to be true. So what we're going to do is we're going to shade in with our pencil or with a highlighter. I don't care. We are going to take the truth and color it bright, bold, and beautiful. I make the truth so pretty. We color the truth. Or use a highlighter. Highlighters are also fine. I also have a gazillion highlighters if you need one. I think that might be the technical number of highlighters I have. Okay. That's cool. Questions on this one? Whoever's got their music on, turn it off. I can hear it over here, which means you can't hear what we're doing, nor can anyone around you. Just as a reminder, we do have a school-wide cell phone policy where your phone is not supposed to be out. And if it is, I can have it, sent to your grown-ups. They have to come and get it. Don't be on your phone. It's like we had our first quiz last week, and I feel like for some of us, we got a little bit of a realism check for how much we've been paying attention. Some of us did really great. Some of us did not do as great. So we need to be working. Okay, let's do one more of this regular one, and then we're going to do a hard one. A hard one, a story problem. We're going to do a problem. Okay. So we've got y is less than negative 1/2 x minus 1. Same process. We figure out if we're doing a dotted line or a solid line. Is this one going to be a dotted line or a solid line? A dashed line. Absolutely right. I'll even write it as dashed. I do not care which word you use. They are the same thing. I have a tendency to say dotted, but dashed is technically closer to what I draw. We are going to graph our related line of y equals negative 1/2 x minus 1. That is the line we're using. So where are we going to start with that line? At the negative 1. That's our point where we're starting, at our y-intercept. That guy. How are we going to move? Only switch one. So if we're going the slope of negative 1/2, we're Rise over run. So instead of going up, we're going to go down 1, still right 2.
So what if the denominator was negative?
It's the same exact thing if the numerator is negative. So I could go up 1, left 2. It's still the same slope. I can go this way. Totally fine. Just flip 1.
Okay.
If you flip both, we wind up back in positive territory. Because that would be a negative over a negative, and that simplifies to a positive. And we are doing a dotted or dashed line using our rulers. When you're not on an iPad, that's a jerk. Close enough. Should look something like that. To pull my hair all the way up. I don't know how y'all are wearing hoodies. I'm about to die over here. It's so hot in here. Okay, we've got to test a point. So we're going to pick any point not on the line. 0, 0 is not on the line. It makes my life easier. That is not the only point you can use. We started using 1, 2. That one would totally work. As long as you can see very clearly it's not on your line, you can use any point you want. But 0, 0 is the probably easiest to use. Because when we substitute it in, we're going to have 0 less than negative 1/2 times 0 minus 1. Substituting in the point 0, 0 into our inequality. So then we're going to simplify that. We want to know, is 0 less than 1/2 times 0? 0. 0 minus 1 is negative 1. So it's okay to take a jump like that. Is 0 less than negative 1? No, it is not. Which means this is not where my solutions are. I need to go on the other side. So I'm going to color where the truth will be, which my truth will be on this side of the line. Anything in this shaded region is truth. And the easiest way to reliably tell which side has the truth is to test a point. Okay? We'll start to notice. Go ahead, Jerome.
I have a question. Is it always true if it's if the greater than or equal sign it's pointing that way, then it will always be on the bottom, but if it's facing that way, it'll always be on the top?
If it's y on the left and x on the right, and y is less than x, it'll be down. And y is greater than x, it'll be up. But that only works if y is on the left and x is on the right. So when we have them that are standard form, that doesn't work at all. We'd have to solve it and get the y's on one side and the x's on the other, which is why I do the test point instead of doing that, because then we'd have to solve this into slope-intercept form. That does work as long as x is on the left, or y is on the left and x is on the right. Yes, dear.
So I have another question. So
Yes, dear.
Like, say like on the quiz,
Mhm.
you have us do this, and say that we plot a false point. Can we just say it there? Is that support, or do we gotta like plot like an actual?
No, you don't. I was like, if you test one,
Uh-huh.
that tells you where your region is. You do not have to test until you get a true one. If you want to, you can. Always a fine way to double check it, but one test point's all it takes. Because that shows me, well, I know it's not here, so I know it's got to be over there. There's only 2 options. Okay? We're going to do one more. And I have a different graph for you. Because it looks different. And we have to write our own equation. Ew. But that's okay. We can do it. So I'm giving you guys one more bill graph all by yourselves. If you get one that has like all the numbers cut off, let me know when I can get you another one. But I was cutting them out. My cutting needle is only so accurate. These numbers are tiny. Okay. So sometimes we're going to get story problems, and we're going to have to write our own equations or our own inequalities. So we've got here a delivery crew is loading a truck with tables and chairs. Each table weighs 200 pounds, and each chair weighs 60 pounds. Those are some light tables and bougie chairs. The maximum weight on the truck is 1,200 pounds. It's a very small truck. We are going to write an inequality for the situation. That is our first step. What's a piece in here that we can see? Something we might be able to use to write an equation. How could I write that each table weighs 200? True. T equals 200, but do we need to know how much each table weighs, or do we need to know how many tables? How many tables? So if each table weighs 200, how much are the total number of tables going to weigh? Yeah, it's going to be times 200, right? If each table weighs 200, if I have one table, weighs 200. If I have two tables, 400, because we have 2 times the number of tables. 3 tables, 600. And we work our way up that way. So the number of tables times however much the tables weigh, right? And then we need to combine that with the chairs, right? Because I can't just have tables. I need chairs too. So if each chair weighs 60 pounds, how could I write about the chairs in the truck?
Let's see, times 60.
C times 60. And you're exactly right. We're combining them together into the truck that has a max weight of 1,200 pounds. Which way is my inequality going to face?
Positive.
Because which side can be bigger? Can this side be bigger than 1,200? No. So that means, remember, the crocodile faces the bigger side. Could it equal 1,200 pounds? Yes. Okay? That's where all these pieces are coming from. The hard part on this one is finding all those pieces. So there's our 1,200 pounds and our maximum weight. That is our inequality. From here, we're going to graph the dang thing, and this is the last one, I promise. This is in standard form. So we can do our kind of cover-up method to get there. So we don't have anything labeled on which side, so you guys can pick which side is tables, which side is chairs. Genuinely doesn't matter. How many tables? If I brought no chairs and just tables, how many tables could we bring? 6. So my intercept on tables, that's not a pen. I could bring at most 6 tables. What if I brought no tables and just chairs?
20.
If I brought no tables and just chairs, my intercept for chairs is 20. That is a C. I don't know why it looks so much like an E. Which I said it out loud, so then I tried to write an E. So those are my X and Y intercepts, my table and chair intercepts. And we can graph that here. So I don't care which axis you use, just label one. I'm going to put chairs on my X because I can. But if you already started doing it and you have your chairs on your Y, I don't care. Put it there. So my Y axis here is going to be tables. And that gives me a 6. We said it is allowed to be equal to, which means we're going to use a solid line. And then since this is a logical situation, we might not even have to test a point. Think it through. Are we going to be shading above the line or below the line? Below, because I know I can't use 8 tables. We already said at most 6. If I bring 8 or 10 tables, my truck's overweight. So this one, we know, has to be below, because we logic our way through it. Okay, so story problems, sometimes you do not need to do a test point, and you can logic your way through it. You can always do a test point. 0 tables and 0 chairs. Yeah, that's less than 1,200. Okay, so these inequalities are the next piece of what we're doing. So I have a homework for you. Homework 1-5. This is for graphing lines and inequalities. So it's going to refresh over the graphing lines as well, which is what we did last week. At the end of the week, so here's 1-5 homework. Tomorrow or the next day. We're flexible. I know like one day is a little much. So if you need an extra day on it, I get that. You get it done for a day. I'm not super big on it. We just got done with that first quiz. Okay, so there's 3 lines to graph on the front, 3 inequalities to graph, and 1 story problem where you're going to try and write your own inequality and then graph it. Okay, so I have it listed as, that is so not true. Holy cow, where did that come from? There we go. Just crossing that out before anyone sees it. It says due Tuesday. If you need until Wednesday, because it's a lot of graphs, I get it. Totally fine. So theoretically tomorrow, ideally Wednesday, or before Wednesday would be great. Okay, but that's all we're doing today. You have about 10 minutes, 12 minutes left in the period. So you can start working on this. The lines you can probably get in. You can maybe get 1 or 2 of the inequalities done. Ask questions, all that jazz.